Hello everyone. Today we are going to see the crash course on alcohol phenol ether. This chapter is super important because this chapter is having lots and lots of important reactions in it, and also some named reactions as well. This chapter includes the preparation and properties of alcohols, phenol and ether. So we very well know about alcohol that is having OH group in it, phenol which is that C6H5OH, aryl benzene ring with OH, and then ether which is having a separate functional group of ROR, R meant for alkyl. So let's start with alcohols. So before getting into preparation of alcohol, I would like to tell you there are three types of alcohol. One is primary, the next one is secondary, and the third one is tertiary. What is the difference between these three? Primary alcohol, which will look like the CH2 group attached with OH. In case of secondary, one carbon is attached with two CH3 group, two substituents with OH attached to it, and then in case of tertiary, 3 CH3 group attached to it to a carbon, 3H3 group or any other substituent. Okay. So why I'm pushing the types of alcohol here, because the questions can be asked for differentiating primary, secondary and tertiary alcohol. In previous chapter, haloalkanes, we saw a reaction which is called Lucas test to distinguish primary, secondary and tertiary. We are going to see that as well. Let's get into the preparation of alcohols first. As we all know, which can be prepared from substitution. The first preparation method is I'm treating haloalkane with aqueous KOH, so it can undergo substitution to give alcohol. That is substitution. The second method of preparation is that reduction from carbonyl compound. RCHO aldehyde upon reduction, which will lead to give primary alcohol. Always remember one thing, if I am reducing aldehyde group, that will lead to the formation of primary alcohol. Similarly, if I am reducing ketone, which will lead to the formation of secondary alcohol. These two reactions, kindly note it down and memorize it and let it be stick in your mind. So how to prepare secondary and primary alcohols from carbonyl compound, which is super important. What about reducing other carbonyl groups like esters, acids and acid halides? Say for example, I'm reducing carboxylic acid. For reduction, I'm using H. You can use any reducing agent, lithium aluminum hydride more specifically. That is a very strong reducing agent. So coming back to the carboxylic acid, while reducing it, it will produce primary alcohol with a strong reducing agent. Similarly, if I am reducing COOR dash, which is ester, that will give you CH2OH. Along with that, another R group will lead to give you an alcohol. So this is important, how ester is giving two different type of alcohols. Acid chloride, RCOCl, Upon reduction, it is again giving you CH2OH. What about anhydrates? Acid anhydrates are C double bond O, O, C double bond O, R. Upon reduction, it will give you 2 moles of RCH2OH. Okay. So as a next part of our series, we are going to solve some questions. So please stay tuned. We'll be posting some mock test questions as well. Whoever registered for NEET crash course, they are also participating in the mock test. So those questions will be discussed there. Okay, the next method of preparing alcohol is that using Grignard reagent. We very well know about the Grignard reagent, that is RMgX. Upon treating it with aldehyde, it will produce carboxylic acid. As you can see, I'm just giving you the hint how it goes. Not going to involve the step-by-step mechanism. You can take a carbonyl group like this. What will happen? RMgX, where magnesium is metal, which is electropositive, then R group. So R goes as R minus and magnesium becomes Mg plus. So it will get attached to aldehyde like this, MgX, and then RH. So followed by hydrolysis, this group becomes RH with OH, then Mg with X and OH group. So you can remember it like H plus and OH minus over here. Okay, so you can follow this method to other carbonyl compounds as well, carbonyl functional groups as well. So please try that out. Again, if I am treating it with ketone, quite obviously, let me take acetone. What that will produce? With Grignard reagent, the R group will get attached to the carbon, and then it becomes OH and CH3, which is a tertiary alcohol. Correct? Then the next important and very familiar method to produce alcohol is that hydration. So RCH double bond CH2 with H2O, it will produce RCHOH CH2, which follows Markovnikov's principle. What are the reagents I'm using here? Which is an acid catalyzed hydration. And this method, which is called hydroboration oxidation, we already discussed about this method in the last chapter. Again, B2H6 or BH3, anything works with the solvent of THF and peroxide, which undergoes anti-Markovnikov. So the product is CH3, CH2, CH2OH. So this follows Markovnikov, and with B2H6, I mean the hydroboration followed by oxidation method, that follows anti-Markovnikov product as a major one. So please remember that. And the last method of preparing alcohol, which includes CO, that is carbon monoxide, with hydrogen in the presence of zinc oxide and chromic oxide. which will lead to the formation of alcohol at higher temperature and pressure. That is 700 Kelvin temperature and 200 atm pressure. So these are the important method of preparing alcohols. One more method is there which we are using it. We are seeing that in daily life, that is called saponification method. What is this? Is it related to soaps? Yes. This is a kind of preparation of soaps, which includes RCOO, R dash. I'm taking the different alkyl groups on the both the sides, treating it with NaOH, which will lead to the formation of RCOONA ONA with ROH. Say for example, if I'm taking this huge compound, C17H33. Ma'am, why are you so specific about this compound? It's because it is a kind of a vegetable oil. While I am treating it with caustic, that means NaOH, it will lead to the formation of our favorite and very important cleansing agent. This is a trihydric alcohol which is having 3 OH groups in it. The name of this alcohol is 1,2,3 trihydroxy propane, which is also called as glycerol. That's why I'm pushing this big group. Along with that, 3 moles of C17H33 COONA has been produced. Okay. Our next target is to cover the physical properties. We're talking about the physical properties of alcohols. The boiling point increases with the molecular mass increases and the branching decreases. That's all they can ask about the physical property. If I'm taking ethanol with ether, the boiling point of ether will be less when comparing to ethanol. Okay, let's move on to chemical properties. It's nothing but the chemical reactions. Let's move on to the chemical properties. I took the little small alcohol, that is ethanol, but the reaction would be same for higher order alcohols as well. The first thing, with red phosphorus HA, it is giving us the long chain compound, the straight chain compound C2H6, that is an alkane. Okay, treating with ammonia, first that will give the primary amine, and then it will give secondary amine, and then finally it will give tertiary amine again and again if I am treating it with 3 moles of alcohol. Then this reaction, I2NaOH, this is super important reaction. Why I am mentioning is that it can be asked, it was asked in so many papers. Okay, I2 with NaOH, it will form iodoform. So iodoform formula is CHI3. If you are treating it with Cl2 with NaOH, that will form chloroform CHCl3. Okay, then PCC or PDC with copper that is an mild oxidizing agent which will lead to the formation of aldehyde, and with strong oxidizing agent that is producing acid. Okay, but mind the number of carbons as well. The number of carbon is not changed. Okay, then concentrated sulfuric acid at 383 Kelvin, it is producing as C2H5HSO4. Just a substitution happened over there. But reacting it with sulfuric acid at 410 Kelvin, temperature is also important. 410 Kelvin, it is giving us ether. Ether preparation also we will use this method. And concentrated sulfuric acid at 433 Kelvin, it is giving an elimination product of ethene. Again, concentrated sulfuric acid with reduced pressure, it is giving you diethyl sulfate. At 0 degrees Celsius, it is just giving us a salt of hydrogen will get added to the oxygen, which makes it a positive charge, and HSO4 minus. And anhydrous calcium chloride it is forming a salt again, and with Grignard reagent it is forming alkane. Sodium, it shows the acidity. This is the test for checking the acidity of ethanol. Alcohol is acidic in nature, so which becomes, it loses the hydrogen and sodium will get attached over here. And ClCOCH3 lead to the formation of C2H5OCOCH3 in the presence of pyridine. These are the chemical properties of alcohol. I told you one reaction, Lucas test, is important for distinguishing alcohol. If I am treating primary alcohol with anhydrous zinc chloride with HCl, that is the reagent, Lucas reagent, it will give you, it will not show any processes, but in case of secondary alcohol, the same reagent, Lucas test, will react in 10 to 15 minutes. After 10 to 15 minutes, it shows the turbidity. That means the reaction is slow with the secondary alcohol. But in case of tertiary alcohol, it will show immediate turbidity. That is the clue point for your questions, which indicates the tertiary alcohol is present over there. Okay, so that is very important test for determining the category of alcohol. It will be useful for your practical purpose as well. Okay, so now let's move on to the phenols. Since it is a crash course, I'm not covering the entire part of what is happening, what are the mechanisms, so I'm not covering anything, but I'm just covering the important part, what you have to memorize, what you have to keep that in your mind. Okay, so please don't move forward, press the forward, don't please press the forward button. Watch it carefully. Phenols, we know that is a very stable and aromatic compound with C6H5OH. The different types of phenol, it's not types, which is depend on the position of substituent, the name varies. The first one, the CH3 group in ortho, which called as, we'll name that as 2-methylphenol. but it is also having an important name, orthocresol. Similarly, if I am having dihydric alcohol, an aromatic ring which is ortho to each other, that is called catechol. As IUPAC name, we will name it as benzene 1,2 diol, but as a common name, that is very famous name, that is catechol. If that is present in meta to each other, then that is resorcinol. If that is para to each other, we know this compound very well, that is quinol, or also called as hydroquinone if that is undergoing the resonance. Hydroquinone or benzene 1,4 diol. Then the method of preparing phenol. I told you in halo chapter there is a method which involves NaOH and high temperature and pressure from halo array. I told the name as well, that is Dow's process. Correct? That is what I am writing over here with 573 to 623 Kelvin, presence of NaOH and 300 atm pressure, which will lead to the formation of phenol, that is Dow's process. The second method, this one also we prepared it from the favorite versatile compound, that is benzene diazonium salt with sulfuric acid and H2O, lead to the formation of phenol. The third method is from Grignard reagent. Instead of R, I am using C6H5, remaining or same. I am taking MgBr. By oxidizing this, I am getting C6H5OH with the elimination of Grignard reagent. Then the fourth method, industrial method to prepare phenol, where I am using benzene with vanadium pentoxide at 315 degrees Celsius, leads to the formation of phenol. And then the fifth method, which is again I am taking C6H5 CH CH3. This method is also important, which is called as cumin process. This involves a step-by-step process. I'm not going to cover that here, but you can refer the cumin process. Maybe I can tell you cumin, which is the compound like this. The compound is important, so that's why I told you this. This is cumin. From cumin I am preparing phenol. If you want, you can go through the mechanism as well, but I am not going to cover the entire mechanism in the crash course. Then the next method to prepare phenol is from benzene sulfonates. That is our last method, which is C6H5SO3H with NaOH and HCl, that is giving us C6H5OH. So these are the methods to prepare phenol, which are the simple processes, but it is asked so many times in the question paper. So please be careful with the phenols. Okay, so one more category of questions from phenol part is that comparing the pKa value. So I can give you a simple hint, which is acidic strength of acid is inversely proportional to the pKa value. So this order can be useful to you while talking about phenols, because phenols are more acidic than alcohols or normal alkyl alcohols. The pKa values of some phenol compounds are, I'm going to list it now. If an electron donating group, that will decrease the acidic strength, while the electron withdrawing group increases the acidic strength. Please remember that. For example, if I am taking orthonitrophenol, phenol in ortho position I am having nitro, which is having the pKa value of 7.2, and metanitrophenol, the pKa value is 8.3, and paranitrophenol, the pKa value becomes 7.1. So these are the differences. If I am comparing it with phenol, that is C6H5OH, the pKa value is 10. So pKa is depend on the electron withdrawing group and donating group. If an electron withdrawing group is present, acidic strength increases, which is inversely proportional to pKa. So lower the pKa, higher the acidic strength if electron withdrawing group is present. Okay. Then if I am comparing it with cresols, cresol, which is nothing but CH3 group present over there, is it? So orthocresol. Orthocresol, the pKa value is 10.2. Metacresol, the pKa value is 10.1, and paracresol, pKa value is again 10.2. So they will not ask you the pKa value directly, but they may ask you the acidic strength. So that's why I'm giving you the pKa values as well. Okay, let's quickly jump into the chemical properties of phenol. We know that is acidic, so with metal that will produce hydrogen gas. Apart from that, there are few important reactions for phenol. Let me write it like this. First thing, bromine water. With bromine water, phenol is producing 2,4,6, which is ortho and para substituted phenol. Bromine occupies ortho and para positions, which is a white precipitate. And if I am treating it with ferric chloride, neutral ferric chloride, this is one of the important clue point. Neutral ferric chloride, it will give you purple color. The purple color is due to the formation of this compound. Mostly they will mention with neutral ferric chloride that is producing purple color, which means the compound is phenol. Then Br2CS2. There we saw bromine water, 3 moles of bromine water. Here we are taking Br2CS2. It is producing ortho and para bromo substituted phenol. Okay, so which means it will be forming ortho bromo phenol and para bromo phenol. So please find the difference between bromine water and bromine with CS2, carbon disulfide. With dilute HNO3, it is producing once again ortho and para substituted different products like this. With concentrated nitric acid and sulfuric acid, which is nothing but the nitration. Concentrated means all 3 positions are occupied with nitro group. So this compound is very important compound that is called as picric acid. Picric acid, that is nothing but 2,4,6 trinitrophenol. Please note down the name as well, 2,4,6 trinitrophenol. Okay, the next important reaction, that is our Scott-Bauman reaction. Why this reaction is important? Because it is one of those named reactions which can be given as a clue point as well. For example, I am taking phenol, treating it with C6H5COCl, which produces which produces C6H5OCO C6H5. The next named reaction, that is very important, Reimer-Tiemann reaction. This named reaction you can see in several previous year question papers. That much important this is. The question can be asked from intermediate, the question can be asked from reactant and product, so what not. Question can be asked from anywhere, from this part. So phenol, treating it with CHCl3, NaOH plus heat, acid catalyzed reaction, which is giving us ortho and para substituted phenol Out of this, para substituted is much major product than the ortho one. Okay, so for this reaction alone, I would like to tell you the mechanism also, because this can be asked in several ways. The first step, formation of carbene. First, I am taking CHCl3 with KOH, that is producing as K plus with CCl3 minus. Okay, along with water will get removed. Again, upon heat, this will produce as KCl with, most importantly, a carbene. We discussed about carbene, singlet carbene, triplet carbene in GOC chapter. You remember? So that carbene is produced over here. The next step is this carbene is going to attack the phenol ring. Step 2, attack of carbene to the ring. Attack of carbene. So what happens over here? Let me take phenol. Always while you are writing the mechanisms, take the phenol with the, not with the ring, with the double bonds. Okay, so I'm having carbene. Now, of course, the base is used which will take up the hydrogen. These electrons will attack the empty orbital of CCl2, and I'm having hydrogen over here. Why? Because oxygen minus are coming into picture, which leads to the formation of the compound like this. H is already there, CCl2 has been formed with the minus charge, and remaining double bonds are intact. Okay, now listen carefully. This minus charge is attracting the hydrogen. So hydrogen leaves here by giving up the electrons and joins with CCl2, which makes it CHCl2, and oxygen becomes O minus. Let me write it clear. As a next step, what can happen? Of course, these oxygens will not be remain same. This attacks again double bond. So this bond have to treat it so that one of those Cl will leave the compound. Double bond O, double bond C with hydrogen, and one Cl will be there. Remaining double bonds are remain same. Okay, now the presence of base. Base is attacking this carbon. Due to that, once again, goes like this, so that O minus, double bond, C, H, Cl and OH. Okay, now again what oxygen will do? Try to join the family so that this bond will get affected. Cl leaves, always the better leaving group, that is leaving. So that double bond O with double bond C, H and OH will be there. Correct? In this case, we almost formed the product. What will happen? Carbon is having a double bond right here. It doesn't want that to be happen. So what happens? This hydrogen leaves as H plus. Due to that, bond shifts. That H plus will be taken over by our O minus to form our end product as CHO. So this is our Riemann-Kremer end product, which is also called as salicylaldehyde. Salicylaldehyde. Okay. So mechanism they won't ask, they will ask you the intermediate part and the carbene formation and how treating CHCl3 which gave with KOH what is forming. So that kind of questions you can expect. Fine. Next we are moving on to the next important reaction, that is phenol with CCl4. CCl4 and NaOH at 340 Kelvin with dilute HCl. It is producing as carboxylic acid. I told you in Reimer also ortho product is the major one. Similarly here also the ortho product, that is major one, that is salicylic acid. Next reaction, that is Golb's electrolysis or Golb's reaction you can take. What will happen over there? C6H5OH treated with NaOH CO2 with dilute HCl at 400 Kelvin, 427 atm. Pressure, which will lead to the formation of again salicylaldehyde, which will lead to the formation of salicylic acid. The next reaction with phenol, it is C6H5OH with CrO2Cl2. It is an oxidation reaction which will lead to the formation of benzoquinone, that is para-benzoquinone. Next reaction, phenol with our benzene diazonium salt. That is super important reaction, benzene diazonium salt with phenol, that is forming as a dye. I'm telling you, this reaction is very important reaction. This dye is orange in color. You must have seen this word in your practicals also. This is orange azo dye. That's it about phenol. Let's move on to ethers. Ethers are ROR. The naming of ethers we very well know. I'm giving you an example, that is, let's say this kind of bit difficult structure, CH3O C2H5. So how will you name it? Start with the smaller groups which is attached to oxygen. So 2-ethoxy, okay, this part. Then 1,1 dimethyl cyclohexane, right? What are the preparations of ethers? We already saw that from ethanol using sulfuric acid at 413 Kelvin lead to the formation of diethyl ether C2H5 O C2H5, and with RX RONA, that is called Williamson synthesis to form ethers. These two are very, very important synthesis of ethers. Talking about the boiling point, ether is more volatile compound. As a molecular weight increases, of course the volatility decreases. Ethers can react with HX, HCl, HBr, like that, to give RX and alcohol. The rate of these reactions will be, HI will be more when compared to HBr and HCl. For example, if I am taking ROR with HI, lead to the formation of RI with RO. If I am treating it again with HI, lead to the formation of Similarly, if I am treating it with excess of HI, which will lead to the formation of 2 mole of Ri plus H2O. Okay, please be careful with limited amount and excess amount. The next part, that is electrophilic aromatic substitutions, we already dealt with this so many times. Here you can see ether that is having OCH3 group. So the incoming electrophile will go to ortho or para positions. Let's say Br2 is coming, the presence of acetic acid, so which will lead to the formation of para bromo anisole and ortho bromo anisole. Out of this, para is major, ortho is minor product. Similarly, if I am treating it with CH3Cl with AlCl3, what that will produce? Bridal graft, alkylation, para and ortho substituted products. Out of that, para becomes major one. Similarly, you can go to with nitration as well, nitration and sulfonation. So these are the important parts of alcohol phenol ether chapter. We'll post one more video which involves the entire named reactions. We already posted it. The detailed named reactions with mechanisms, we'll post that very soon. Until then, practice more and more questions. Thank you.